Hi everyone, I continue here. So here I am adding these numbers. So let me fix the problem again. Yeah, I hope it's working very well. No. Okay, so and so I want to add and subtract. These are good practice and good exercises for your brain to learn about like terms. They are very good practice for algebra. When we work with algebra, then for example we add like terms that they have x and y, and they have the same x, the same y, the same variable to the same power, for example. So we can start from here and work on these. Okay, so here I would say I have 2 radical 27 plus 5 radical 3 minus radical 9, and then you would say none of them are the same, so how can I add them? One of them radical 27, one of them radical 3, one of them radical 9. So then I say, how about if you do that? Because I have radical which is root 2, so I have to do this. I have to have something power 2, so I borrow 3 power 2 from 3 power 3. So maybe I can do say step by step. So 3 power 3 and plus 5 radical 3 and minus that, and then it is 2 sorry equal, so equal 2 radical 3 squared 3 plus 5 radical this minus that equal, and which is I can bring 3 out, so it is 6 radical 3, okay, plus 5 radical 3 minus 3, and this is 11 radical 3 minus 3. That's the answer. Okay, so as I said, these examples, they are really helping you in future for algebra when you are adding and subtracting. Based on my experience, when I teach Math 273, students are really in need of more practice on algebra. And in order to do more practice on algebra, you have to see more questions similar to algebra. So we have to do addition, subtraction with like terms. And so why not here? We can start from this part. Okay, so how about this one here? So look at this. You have radical 27 minus radical 98 plus radical 32, which I can say it is radical 3 squared 3 minus radical I think 7 squared multiple 2, I think so, yes, plus um, plus 2 multiple 4 squared, okay, and then I have 3 radical 3 minus 7 radical 2 plus 4 radical 2, and which is 3 radical 3 minus 3 radical 2. Why? Because they are like each other. These two are like each other, but this is not like them. So that's separate, okay? Okay, so they are good practice for in future algebra. So how about this one? So how about this one? So you can work on different questions. So one of them is this. So and then we go to multiplication. So here I can write this one here. So 2 radical 27 minus 3 radical 50 plus 5 radical 12 minus 4 radical 8. Okay, which is 2 radical 3 squared 3 minus 3 radical 5 squared 2 plus 5 radical 2 squared 3, 2 squared multiple 3, 3 minus 4 radical 2 squared multiple 2. And then which one you bring out? So you bring this out and this out and this out and this out. So it is 6 radical 3 minus 3, so minus 15 radical 2 plus 10 radical 3 minus 8 radical 2, and then this one and this one, and then this one and this one. So it is 16 radical 3 minus 23 radical 2. Okay, Remember, radical 2, radical 3, they are not like each other. They are very good practice for numbers as well as algebra in future. Okay, so how about, for example, multiplication when you have radical. So here you can see these rules when you have radical, and for example you have the same. It's the same. You have a power 1 over 2 multiple b power 1 over 2. So you multiply them. Do you remember this? We had a power. So I said x power a. Oops. X power a y power b. So sorry, y power a. It is xy power a. This is the same thing here. When you have a power 1 over 2, because it's fraction, b power 1 over 2, then you do ab power 1 over 2. Okay, so the same thing. So what happened here then? Here it is radical 6. Okay, so how about here? Here it is 3 multiple 6. Why? Because you have 3 radical 36, which is 3 radical multiple 6, which is 18. How about here? You multiple number, radical, the same. Things the same. In future in algebra, you see something this similar to this. So it's 8 radical 6, because you multiple. So look at the question here, the formula here. Look at this formula here. You multiple under the radical. You divide under the radical. So the same. 5 radical 35 x squared. Okay, which is 5. So absolute value of x radical 35, because I have x squared, I have to bring x out, and it must be positive. So I just bring. So maybe I can say x is positive for sure. Otherwise, that doesn't make any sense, because it will be negative under the radical, and then I can do this. Okay, number with number, radical with radical. Okay, so here you can do practice on these. Okay, 1 plus 2 minus 4. I have 1 apple, and I have 2 apple, and I have minus 4 apple. So it is 1 plus 2 minus 4 radical 6, which is minus radical 6. How about this one? I have 5 radical 3. So I have this one and this one alone. Okay, so it is 7 radical 3 minus 2 times 2, which is 7 radical 3 minus 4. Okay, number now. So 4 times 3 times 2 radical 2 times 2 4, 4 times 5 20. Okay, and then we can simplify after. Okay, so for example, I can say here 4 times 3, so it's 12. Okay, 4 times 3 times 2, and radical 2 times radical 2 times radical 5. Okay, so it is 12. Okay, so this one and this one is also 2. Okay, because it's radical 4, and it becomes 2 then. Okay, so you do 12 times 2, 24. So 4, 16, 48. So it's 48 radical 5 then. Okay, so how about this one here? So this one is 4 radical 3, 8 times 3, which is this and this cancel. So it's radical 3 over 6. Yes. Okay, so the same. So here, so from now I'm just doing practice. I'm just doing practice, more practice, because practice makes perfect. And also sometimes I see a student, they make mistakes, so I just write down many practice and many questions for them, just in order to talk about those mistakes. For example, here, if I want to see with positive exponent, do I do 1 over 4x? Or no, that's wrong. I just do 4 over x. Which one is correct? 4 over x. Because x is to power minus 1, not 4. So 4 stays up. But here 2b is inside the bracket, so it is 1 over 2b. Yes. How about here? X stays up over 2y because 2y together is in the bracket and to power minus 1. How about here? Do I need to be worried about inside? No, the answer is just 1 because it's power 0. Okay? How about here? 2 over x power 2. 1 over 3a. So I want to show it with positive exponent. Okay? So I say. So y over 3w power 2, which is y over 9w squared, for example. Okay, I see mistakes related to these and I like to talk about them. So here is 1, just 1, because I have power 0. I don't need to worry about inside. Here, I recommend flip and change the power to positive and then deal with the power. So it is 9y squared over 4x squared. But if you want to apply power minus 2 first, then it will be confusing. So I recommend flip, change the power to positive, and then continue. How about here? Here you have to just simplify. Number with number. Okay. So 1 over 2. X power 3 minus 1. Y power minus 2 minus 1. Which is 1 over 2 x power 4 y power minus 3, which is 1 over 2 x power 4 y power 3. The only thing I move is this one because it has power, so negative power. How about this one? As I said, you have negative exponent, flip them, don't change them. Okay, so 3xy over x cubed y minus 2, and then I simplify. So it is 3y 1 minus 2 over x squared because I can cancel, which is 3y power 3 over x squared. How about this one? So for these you have to just simplify. Okay, simplify. So 1 over 3. So simplify this and this. Okay. Then change the color, x power 3 minus 1. Then change the color, so y power minus 2 minus 1. Then change the color, z power 2 minus 0. Okay, so I don't need z power 0 is 1, which is 1 over 3 x power, oops. Yeah, so x power 4 z power 2 over y power 3, right? Yes. How about here? And how about here? And then we are done. Okay, so these are good examples, good practice for you, which I added to the lesson. Okay, so 4 and 2. Can I simplify? Yes, 2. X power minus 2 minus 3. Y power 4 minus 2. Z power 2 minus 1. Which is 2 x power minus 5 y power 2 z power 3, which is 2y squared z cubed divided by x power 5. The only thing you move, I want to emphasize, I want to show you this on many examples. How about this one? This is a very good question. Sometimes I give this question, a student, they try to simplify and flip, and at the same time they want to do everything at the same time. They want to apply this and they want to simplify inside at the same time. That's wrong. Do it step by step. First I flip it, no change. The same thing. Up, goes down, down goes up. 4 x power minus 3 y this and this divided by 12 x this equal 1 over 3. Yes, I cancel. X power minus 3 minus 5, y power 3 minus 1, z power minus 3 minus 4 power 2. Okay, and then I apply power 2. That's easier. If you want to do one by one, it's confusing because you want to apply 2 to each and then simplify. That's wrong. That's not wrong, but it's more, you need to do more work. The more work, the more chance of mistake. So yes, yes, yes. So this one minus 8, 2, and yeah. So it is this, 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 and this one power 2, which is 1 over 9 x power minus 16 y power 4 and z power minus 14. You times 2 to the power. That's rule. Power on power, you times powers. And then what do you do after? Y power 4 over 9 x power 16 z power 14. You just move this and this one, nothing else. Okay, for me it's very important that I do these examples for my students because then they learn it and they don't make these mistakes in the quiz and test. Okay, that's why I added these simplifications here. So these simplifications, power, negative power, inside the bracket, outside the bracket, so these things are very good for you to see how to add and subtract like terms. In future we are going to do algebra, and in math 273 sometimes based on my experience I see students they need more work on algebra. So why not we start earlier than we go to algebra so we can work on this, so we can learn how to multiple like terms, how to, for example, simplify, add, subtract those. Okay, so I really appreciate. So after this I'm going to start